Hi students, in this class we will discuss about disaccharides. How to form disaccharide in this class we will discuss. Disaccharide. So in this is also belongs to biomolecules chapter. So disaccharides. Example of disaccharide what? On hydrolysis of, first of all, on hydrolysis with dilute H2SO4, on hydrolysis of disaccharides on hydrolysis with dilute H2SO4 or HCl or enzyme HCl or enzymes to form two molecules of either same or different monosaccharides will form or already I said no, to form two or more either same or different monosaccharides will form or on hydrolysis with dilute H2SO4 and HCl or enzyme to form two either same or different monosaccharides will form. Okay, two monosaccharides are joined together. Two monosaccharides are joined together by oxide linkage by an oxide linkage formed by the loss of water molecule. This oxide linkage formed by the loss of water molecule. So monosaccharides are two joined, loss of water molecule. With the help of one oxygen, it will form one oxide linkage with two molecules. Two monosaccharides between oxygen atom is there. That oxygen we will call, if two monosaccharides will join, in that one oxygen atom will join two monosaccharides. That oxygen atom we will call glycosidic linkage. Glycosidic linkage we will call, that is glycosidic linkage. Sorry, what is disaccharides example? First one is sucrose, second one is maltose, third one is lactose. So about these three we will discuss. We will call sucrose. First one, sucrose is alpha D glucose plus beta D glucose mixed to form sucrose. Alpha D glucose, beta D glucose, where it is attached C1 and C2 carbons form a linkage, C1 and C2 carbon. It is hydrolysis to give a equimolar mixture of D glucose and D fructose. Alpha D glucose and sucrose, alpha D glucose and beta D fructose. I wrote here glucose, fructose. Okay, glucose, fructose. It is comes from sucrose. So these two mixed means we will get sucrose. How I will tell now. So about sucrose, first one, these two monosaccharides C6 C12 H22O6 plus H2O hydrolysis, we will get equimolar two compound, that is C6H12O6 plus C6H12O6. So one C6 is this one is glucose, this one is fructose. Okay, one is glucose, other one is fructose. These two monosaccharides are held together or held together with glycosidic linkage. How it is linked, I will tell. So this is non-reducing sugar. This is, that means sucrose is non-reducing sugar. Both will form glycosidic linkage or bond. Glycosidic linkage or bond. How it will form, I will tell. So now alpha D glucose structure is this one. So this one is alpha D glucose. This one is alpha D glucose. Alpha D glucose structure. Okay. Here CH2OH, here H, here H, here OH. Next here OH, here H, HOH, here H, OH. This is alpha D glucose. Difference here only alpha D or beta D also. Alpha D glucose plus, we want sucrose means we will two joined. What is that two? One is beta D glucose, alpha D glucose, other one is beta D fructose. Beta D fructose. So what is beta D fructose? Last class we discussed fructose structures. Fructose have 5-membered ring only, no? So this is fructofuranose. Fructofuranose. 5-membered. This is 6-membered ring. Okay. Here H, CH2OH, here CH2OH, here is there, here one OH group is there, here inside H, here inside OH, here H, here OH is there. So from here H2O will remove, H2O. So removal of H2O, we will get water. So that only sucrose. So that compound will come like this. O like this. So here H is there. Sorry, it is not visible for you. H is there. Here CH2OH. Here OH inside H, HOH. Here CH2OH also is there. From here only one hydrogen lost, here OH lost. Then H, CH2OH, here HOH, OH, H, then HOH. So that is, this one is, we will call glycosidic not, that is glycosidic only, GLY, glycosidic linkage. So this is now sucrose. Sucrose, how it will form? Alpha D glucose and beta D fructose, both will mixed, either loss of water molecule, we will get glycosidic linkage, and sucrose we are getting. So sucrose is dextrorotatory. What is dextrorotatory, sir? See, I will tell. Sucrose is dextrorotatory after hydrolysis. So glucose, after hydrolysis, glucose is there, no? That will glucose 1 fructose is there. Glucose is dextrorotatory. How much it is rotate? Plus 525 degrees. That means 52.5 degrees it is rotate. On hydrolysis, after hydrolysis, we will get 1 glucose, 1 fructose, no? Now fructose levorotatory, how much? Levorotatory, how much? This is minus 92.4 degrees it is rotate. This one is like this. So dextro and levorotatory, glucose and fructose, no? But sucrose, what? Dextrorotatory. Sucrose is dextrorotatory. Glucose is after hydrolysis of sucrose, we will get two different structures. One is dextrorotatory glucose, other one is levorotatory fructose. So dextrorotatory changes into this overall mixture now, levorotatory, no? Overall mixture, because this is minus 92 is more than 52, no? So that only sucrose is dextrorotatory, a mixture is levorotatory fully. Now this one we will call fully, this mixture now levorotatory, levorotatory. So that only we will call it is inverted sugar. Sucrose is inverted sugar. Why we will call sucrose is inverted sugar? Now you know. Sucrose is dextrorotatory, but on hydrolysis of we will get two monomers. One is glucose, other one is fructose. Glucose have dextrorotatory 52.5 and fructose is levorotatory 92.4. So 92.4 is more. So that only in these two monomers we will get levorotatory. So that only we will call this is dextro changes into levo changes into dextro. So this levo changes into dextro changes into levo. Because of that, we will call this sugar is inverted sugar. Why we will call inverted sugar? Mean this is sucrose is dextrorotatory. After hydrolysis, we will get two monomers. That mixture is levorotatory because of fructose have 92.4 rotation is there, degrees rotation. So that only levorotatory, like we will tell. Now maltose, second one is maltose. So maltose means it is a malt sugar. Malt sugar also we will call. So it is attached to C1 and C4 carbon. So before I said sucrose is C1 and C2, no? Where it is sucrose and C1 and C2. So now in this one I said it is here C1 and C2 connected to each other, I said. So this is first carbon for fructose, this is second carbon. Where I am writing, you are seeing okay. See, this is the red pen, I will. This is first carbon, this is second, third, fourth and fifth, sixth, like this in fructose. Here this is 1, 2, 3, 4, fifth carbon and this is sixth carbon. Now 2 and 1 carbon only join, no? Here I will tell. This is second carbon, this is first carbon. This is first for this one. Now 1 and 2 carbon only joined. So that only sucrose will join with a glycosidic linkage at first carbon of glucose and second carbon of fructose. Okay, next this one, maltose. So maltose sugar, also malt sugar we will call it, is a mixture with connect with C1 and C4. So it is formed composed of 2 alpha. It is composed of 2 alpha D glucose molecules or glucose units. 2 units, 2 are glucose only, alpha D glucose. Second one, C1 of 1 unit, C carbon 1 of 1 unit and C4 of other unit form what? Glycosidic linkage. This is having free aldehyde group. This is having, which is maltose. This is having free aldehydic group. So that only aldehydic group. So this is having free aldehydic group at which carbon? At C1 of carbon 1 of second C1 of second compound, second glucose, otherwise second glucose, 2 glucose alpha D glucose. No, in that C1 of second one will form aldehydic group. How it will form I will show you, then you can understand. Next, it is reducing sugar because this is reducing sugar. Why it is reducing sugar? Due to formation of aldehyde only. It is having aldehyde group, that's why this is reducing sugar. So it is given positive test, failing solution and all we discussed in one day. That only this one. So aldehyde group present, it is reducing sugar. Not there means it is not given any positive test for failing solution and Tollens reagent also. So aldehyde group is there, it will give positive test. That's why it is a reducing sugar. Maltose is even it is all monosaccharides are reducing sugars, but it is a disaccharide, even also it is having reducing sugar. Why I will tell. So structure I will draw, then you can understand. 2 alpha D glucose means down anomeric carbon, down we should write OH. That only different. CH2OH here H, here H and OH, here OH and H, here OH and H. This is alpha D glucose. Okay. Next plus same one more carbon, one more compound we will take, one more alpha D glucose. See here H, here OH, HOH, OHH, here OHH, CH2OH, here H. So from here H2O we can remove, minus H2O we will get like this, we will write. Okay, so here HOH, HOH, OHH, CH2OH and here 1H. Same here H, OH, H, OH, H, OH and H, CH2OH, here 1H. So this linkage we will call alpha linkage also. Why alpha linkage? This is alpha D glucose, This is also alpha D glucose. No, the linkage we will call glycosidic linkage or alpha D glucose, alpha linkage also we will call. So here, sir, where sir aldehyde group will form? Where you said no? Yes, I said aldehyde means you know that C double bond O H only, no? So this is aldehyde. It will come here. This one, this hydrogen or this hydrogen will goes to here. That compound now OH, here break is there, here C is there, double bond O and H. So that means CHO only aldehyde group. So this is CHO. This side one R is there, R. So that one, you know, this is this side R, C double bond OH. This is, so it is not visible. We want aldehyde group means CHO. CHO, this R is this side. Here C, this hydrogen will join here. It will end like OH. I will show you that diagram here. Like this is only I will draw CH. Like this is there. C double bond O H will come here. Already here one H is there. That this H I am writing with along with this one. So that one like this. This is now what? Aldehyde only, no? Aldehydic group. So maltose have aldehyde group. That's why it is a reducing sugar. Where it is carbon number, I said what? At second glucose. This is a first glucose. At second glucose, first carbon, 1 carbon, 2 carbon, 3, 4 and 5th, 6th. So glucosidic linkage will form where? 4th carbon and 1st carbon. So first carbon, 2nd carbon, 3rd carbon, 4th, 5th, 6th. So first carbon and 4th carbon will form glucosidic linkage. So first carbon have aldehydic group. This is about maltose. So next one, lactose. Third one is lactose. Lactose also known as milk sugar. It is also C1 and C4 will form glycosidic linkage. But this is galactose. This is composed of galactose, not glucose. This is different. Galactose. That galactose is beta D galactose and beta D glucose will join with glycosidic linkage. So where it is C1 of galactose, and C4 of glucose. Galactose will form a glycosidic linkage. C1 of galactose, C4 of glucose. It is also reducing sugar. Which disaccharide is reducing sugar? One is maltose, second one is lactose. These two are reducing sugars. Why? Because they have free aldehyde group formation. So I will tell aldehyde group again. This one also reducing sugar. Aldehydic group. Aldehydic group is present. Okay, aldehydic group is present. So diagrams I will draw. Galactose different water, like it is also glucose, but OH group is different. Both are 6-membered rings only. Galactose and glucose also same. Here generally glucose have this side 5th carbon, 1, 2, 3, 4th carbon OH down is there, H above is there, CH2 OH, here H, here OH, H, OH, H. But here this is alpha D glucose, no, OH down is there, H up. If it is beta D means this OH up will come. So it is beta D only, no, sorry, beta D glucose. So beta D glucose means OH H, like this will come. Yes, correct. Now galactose what? Galactose means here OH, here H. Generally here OH H. Galactose have this OH up, this side OH also upside is there. Here H, here H. This is galactose. Same remaining all like glucose. Here H, here OH. Here CH2OH. Here one hydrogen. Same all, but this OH also upside is there. The glucose is this carbon OH upside is there, means that is beta. OH down is there, means that is alpha. Okay. OH up is there, this is beta. Okay. Here also like this is also beta, no? Beta D galactose, no? So beta means upside this OH, like here both are beta. Here OH upside is there, here also upside is there. Beta D glucose, this is galactose, no? Difference what? Here generally glucose have OH is down, this OH fourth carbon OH, but this fourth carbon OH also up. That is the difference. Okay. Alpha D and beta D difference what? This one, this carbon, what is this carbon? Anomeric carbon, OH group down is there, means that is alpha. OH group up means that is beta. That's okay. That is glucose about. If galactose means what? Beta means up OH like this one. Galactose means this side fourth carbon OH also upside is there. Now loss of water molecule H2O, here also we will get formula like OH H CH2OH, here H, here OH H, here H OH, here means down hydrogen is there, up O like will come. Like this. So here up what hydrogen, here also here down hydrogen. So this is OH bond. Here CH2OH, here H, OH H, OH H, here OH H. So now this one is we will call beta linkage, no? Because all both are beta D galactose, beta D glucose. So beta will form one linkage, that is beta linkage or glycosidic linkage also. Beta linkage or glycosidic linkage. So here also this hydrogen will goes this oxygen minus hydrogen is plus, like it will goes here. Now C double bond O will form. This is hydrogen CHO. This is one more carbon. So it is like C double bond OH, like aldehyde group is there, no? So that only it is reducing sugar. It is reducing sugar. Okay, thank you. Next class we will discuss polysaccharides.